Welcome to YouTube channel scientific underscore math, and we are discussing solving a system of linear equation using the Gauss elimination method. And in last two lectures we have already discussed the Gauss elimination method and the MATLAB code for the Gauss elimination method. I will provide the link in video description. You can watch. Okay. So, in this video lecture, we discuss the Gauss elimination method with pivoting. And before we discuss the pivoting, we will discuss some difficulties that we are facing when we applying the Gauss elimination method. That are the pivot element is zero and the pivot element is relative some is small relative to the other terms in the pivot equations are the pivot row. Okay, so in this video we will discuss these 3 points, definition of the pivoting with example, and the two difficulties which are facing during the applying the Gauss elimination method. Okay. So, difficulties when applying the Gauss elimination method. Number one, when the pivot element is zero. Okay, so since the pivot row or the pivot equation is divided by the pivot element, of a problem will arise during the execution of the Gauss elimination procedure if the value of the pivot element is equal to 0. Yes, we have already discussed the Gauss elimination method, and we also know about the Gauss elimination procedure when we applying the Gauss elimination method. We divide the pivot equation with the pivot element, and here when the pivot element is 0, we are facing some difficulties. For example, we have the two system of equations, and this is the pivot equation, and this is the pivot element. Okay, so when we applying the Gauss elimination method, we divide the pivot equation. Okay, in with, and this is the pivot equation. Okay, pivot equation is divided by the pivot element. Okay, so pivot element, like that, the pivot equation, and this is the pivot equation, and we divide the pivot equation with the pivot element, and when a11 is equal to 0, and then we know that this is the undefined form or infinity. We face difficulty to apply the Gauss elimination method when this is equal to 0. Okay, so we can this problem can be resolved by changing the order of the row or the equation in the Gauss elimination procedure. This is called the pivoting. This is called the pivoting. Okay, so next, the pivot row or the pivot equation that has the zero pivot element is exchanged with another row that has a non-zero pivot element. So changing the order of equation or the row when the pivot element is 0 is called the pivoting. Okay, so for example, we have a system of equations, and here we can see that this is the pivot equation and the pivot element is 0. Here we write this in augmented matrix, and we can see that this is the pivot row and this is the pivot element, and which is 0. So what we will do, we exchange the this row with and this one that has non-zero element. Okay, so we exchange R1 with R2, and this is the final form of in the matrix, and we can see that here now we can applying the Gauss elimination method. Okay, so this is the first difficulty when the pivot element is 0, and we remedied this problem by exchanging the order of the equation. And the next difficulty is the pivot element is small relative to the other terms in the pivot equation or the pivot row. For example, Significant error occur due to rounding when the pivot element is small relative to the other terms in the pivot equation, and so this is the error occur. Significant error occur when the pivot element is small relative to the uh, relative to the other terms in the pivot equation or the pivot row. Okay, so for example, we have these two equations, and we can see that this is the pivot equation, and we can see the pivot element is very small relative to the other terms, like that a12. Okay, so the exact solution of this system is x1 is equal to 10 and x2 is equal to 1, and we find the solution of this system by applying the Gauss elimination method. And before applying the Gauss elimination method, we round these numbers to the four significant digit. Okay, rounding to four significant figures. Here we can see that this one is rounding to the four significant, and this is already four significant, and this one is also already four significant figure. Okay, so now we apply the Gauss elimination method to find the values of the unknown. Okay, so step 1, multiplying the equation 1 with this term. Okay, we know that we multiply this one and divide by this one with the pivot equation, and after applying we get this one. Okay, so and subtract from the equation 2. This is our equation 2, and after subtracting we get this equation, and now we have new system of equations. This is the first equation, and this one is the second equation. So in this equation we can see that after applying the Gauss elimination method, this term is not completely zero, but this term is small. Okay, note that this term is not zero but very small. Okay, so we neglect these terms and we find the value of x2 from this equation, and after some simplification we get the value of x2 that is equal to this one, and we substitute this value in equation 1 and we get the value of x1 is this one. Okay, so we can see that here we have already given the solution of the system, that is x1 is equal to 10 and x2 is equal to 1. So this is the wrong solution when we apply the Gauss elimination method, and here we can see that here x is 10 and here x1 is 33.33 and x2 is approximately same. And okay, so this is the problem we are facing due to the significant error, and when the because the relative because the pivot element is relatively small to the other terms that in the pivot equation. So we can also remediate this one. Okay, so this solution is obtained for the x1 is obviously incorrect. The incorrect value is obtained because the magnitude of the a11 is small when compared to the magnitude of a12. So this problem can be easily remedied by exchanging the order of the two equations. Okay, so for example, this was the second equation, and this was first one. Now we have changed the order of these equations, and here this is the pivot equation and this one is the second equation. Okay, so now again we apply the Gauss elimination method, and we will find the values of the unknown x1 and x2 using the Gauss elimination method. So here we applying the Gauss elimination method, and step 1, multiplying the pivot equation with terms. This one 0.003 divided by the pivot element 0.4321, multiply the pivot equation. What is the pivot equation? This is the pivot equation 4321 x1 and plus x2 is equal to 5.321. Okay, and subtract from the equation 2, and then we subtract from this equation. So after subtracting and substituting, we get the value of x2 is 1, and we substitute this equation, this x2 in equation 1, and we get the value of the x1 is 10. X1 is equal to 10 and x2 1. So the solution now is obtained is exact solution. Okay, so in general, more accurate solution is obtained when the equations are arranged and rearranged every time a new pivot equation is used, such that the pivot equation has the largest pivot element. Okay, so here we have studied the two difficulties we are facing when we apply the Gauss elimination method. Number one, okay, Number one, when the pivot element is 0, and the number two, the pivot element is small relative to the other terms in the pivot equation. So we have solved this problem by doing the pivoting, okay, by doing the pivoting, and we have got our correct solution by doing the pivoting. Okay, so in next lecture, we will discuss the Gauss elimination method with the pivoting, and we will also write a MATLAB code for the Gauss elimination method with pivoting. And thank you so much for watching my video. Please subscribe my channel scientific underscore math for more videos and updates.